4 is called carbon tetrafluoride, but we'll get to naming in the next chapter. What we want to do is represent this compound visually, how it's arranged in space. The very first thing that we're going to do is we're going to list how many of everything we've got. So in this compound, how many carbons do we have? 1. In this compound, how many fluorines do we have? 4. Oh, you guys are good. Okay. We want to count up how many valence electrons we're going to have in our finished structure. So how many valence electrons does carbon have? 4. Yeah. 4 times 1. So we have 4 valence electrons in carbon. How many valence electrons does fluorine have? 7. So we have 7. So this is valence electrons times 4 fluorine atoms. So how many valence electrons will that contribute? 28. So our total valence electrons that we're going to have in this finished structure is what? 32 valence electrons. Okay. Now, the easiest, I find the easiest thing to do is this. We have to figure out what atom is going to go in the middle. And the atom that's going to go in the middle is whatever is most electronegative. So, if you look at your periodic table, grab your handy dandy trusty periodic table. There are 2 rules, I should say, for figuring out what goes in the middle. Either the most electronegative or carbon. So in this case, which is more electronegative, carbon or fluorine? Fluorine. Which is carbon, carbon or fluorine? Which is carbon? I'm going to pelt you with carbon atoms. So, since we have carbon present, carbon goes in the middle. Even though fluorine is incredibly electronegative, it's the most electronegative atom there is, because carbon is present, carbon is central. So what we're going to do is stick carbon there, and we'll draw our little electron dot diagram of carbon. So we know, because on each side, remember these sides are imaginary, this is not a realistic representation of the structure of carbon, but we know that there are 4 sites for attachment. Okay? Carbon can bond on all 4 sides. So let's start by placing our fluorines around carbon and drawing our dot diagram. We know that fluorine has 3 sides that are full. And what do we call those things that are on the sides? Unshared electron pairs, unshared pairs. And we know that up here, fluorine's got 1 electron. Well, guess what? That plugs perfectly into that side where carbon has 1 electron. So if we imagine, we can just sort of pop this in, and it plugs in. Isn't that beautiful? Doesn't it make sense? Trust me, they do get trickier. We start off with easy ones. Okay, so now we've got 2 fluorines. How many fluorines do we need? 4. So we're going to put another one right up here. And guess where our last fluorine goes? I know this is really hard. Over here! You never would have predicted that, I'm sure. Okay. Now, what we typically do when we're all done is any place where we have 2 atoms that are sharing a pair of electrons, we erase that and we put in a single line. If you did this in pen, you would just recopy it. That's fine. Now what we need to do is count up all the valence electrons and make sure we have how many? 32. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. How many electrons does this line represent? 2. So 24, 26, 28, 30, 32. Done. That's the Lewis dot That's the Lewis structure, is what they're typically called. That is the Lewis structure for carbon tetrafluoride. Okay? Reasonable? Good.